All right. Hello, everybody. Good morning. Welcome back to Comp 2450 Software Development 1. In today's class, I'm going to be using Visual Studio Code. I had this up on the screen before class today, but I'll just draw it to your attention now. If you want to follow along with the thing that I'm going to be doing in terms of taking our domain models and starting to have a digital representation of that, you will find it helpful to install this extension in Visual Studio Code before we get to that point. I have installed this extension in my own VS Code. I've used it before, so I can like semi-vouch for it. I haven't read the source code. I don't really know what it does underneath, but I've used it before. So this is something that you can install if you want to follow along with today's class. And I've put a link directly to this extension in the extension marketplace in today's lecture section for our section. So what I want you to be able to do by the end of today's class is we're going to continue with domain modeling, but we're going to move on to add diagram to design. Last class, we were really focusing on the design of our domain model. And today what I want to do is continue with design, but I also want to add diagram here. And I want to do this in a more formal way than what we were doing last class. So what I want you to be able to do today is I want you to be able to draw a UML class diagram given references to resources. So I'm going to give you some references to resources. I'm going to just do some of these things in class, but I'm going to give you like the comprehensive documentation of what you need to do this thing on your own. I want you to be able to make some choices about the properties or attributes of classes in our domain model and their types. And finally, what I want you to do is I want you to be able to make some choices about the behavior of classes in our domain model using some software design principles. So we've seen a couple of software design philosophies in this class, so KISS and Yagni, but we're going to move on to software design principles that I'll mention this when I get there, but these are more like rules as opposed to philosophies of trying to minimize things. So first and foremost, let's remind ourselves of what we saw last class. The main idea of domain modeling is that I want to take these high-level concepts and abstract ideas that are in the problem that I'm trying to work on and represent these things abstractly and at a high level. And I want to be able to represent their relationships with each other without really thinking about implementation details. So the goal here is to try and build this stuff in a non-technical way. I don't really want to think too much about how things are actually going to look underneath in terms of what my Java classes are going to look like. We had two goals that we identified last class. One is that I want to be able to communicate with peers and people using non-technical language. In class, we're kind of doing this by ourselves, and we can look around the room, and we all know that everyone in this room has succeeded at Comp 1020. We know that we've gotten that point. We all have the same kind of technical background in that sense. But when we're starting to work with projects like this, we're going to be starting to have to work with people who are the actual experts in that domain who are not us. And we want to be able to have a common language to use when we're communicating with those people about what the software is going to be doing. And so we want to have this non-technical language to be able to describe these high-level ideas that we're going to represent in the software that we're building eventually. Related to this is that it's giving us a clearer sense of what we're going to build. We don't exactly know what we're going to build yet. You probably have some really solid ideas in your head about what playlist looks like. You know, public class playlist and then like types and stuff that you'd put in there. But we don't always have exactly that image in our mind as we're going through this exercise. But it gives us a clearer sense of what we're going to build. It's giving us a clearer sense of the thing that we ultimately want to get out of this application in the end. And so here was the domain model that we came up with last time. The domain model that we came up with last time for our set of classes that represented this statement of, I want to be able to have some software that manages songs and playlists. I want to be able to put songs in playlists. We came up with these three classes that were the minimal representation of that idea without all the other extra classes that we came up with. Again, I think a lot of those were really good ideas, but in terms of keeping things minimal and to the point of what we actually want to build, these are the three classes that best represented that. So thinking about those two design philosophies, KISS and Yagni. As we were coming up with this, we also identified the relationships between these classes. Album and playlist, I've got this ... line here that says maybe these things could be related, but in terms of what we were doing last class, the two main relationships that we had were between album and song and between playlist and song. With these relationships, we also labeled them. We labeled them to kind of say that this relationship is different from the other relationship that we have here. And what we're trying to say or communicate by using these different kinds of relationship labels is ownership of the data, so ownership of the instances in the relationship. Composite here, so composed of, an album is composed of a song. The relationship that we have here is effectively saying that if an instance of album is destroyed, then all the attached instances of song should also be destroyed. An album owns a song. The song should not exist independently of the album. These are how these two classes are tied to each other. With playlist and song, we've got an aggregation. This means that there is a relationship between these two classes. They're going to be connected to each other somehow, but the ownership here is that playlist does not own song. It has a reference to songs, but if I destroy an instance of playlist, the aggregated references to songs here should not also be destroyed. They can exist independently of playlists. A song does not have to be on a playlist in this system. Our minimal diagram here was fine. This is a great start. I think that this is a really good start in terms of beginning to think about this idea of domain modeling. We did this on pencil and paper. I mean, like, you know, I have a tablet and I'm doing this with a pen that's not an actual pencil. Many of you, I recall, actually got pencil and paper out, which I thought was great. I thought that was really cool. And pencil and paper really are okay. One reason that they're really okay is that this kind of forces us to step away from our machine. This is not a bad thing. Yeah, we are going to build software, but remember that one of these goals is that we're trying to work with people effectively who are non-technical people. Forcing us to step away from our machine kind of forces us to step away from our editors, and it forces us to step away from the JDK, and it forces us to like actually talk to those people. It forces us to step away from our machine and our screen, and it kind of helps with thinking about things in a non-technical way. Pencil and paper are great because it's a lot easier to work with other people. Again, I know many of you pulled your own sheet of paper out. I didn't actually see anybody working together here, but it's not entirely uncommon to get a giant sheet of paper, you know, an A0 sheet of paper, and give everybody a marker. There is little to no barrier to entry to working with a marker and a giant sheet of paper. It's super easy to work with other people when you have physical items that you're working with. It can be a lot easier to work with other people, especially because you don't really have to worry about the technical details of how this thing works that you're trying to get with that person. You just give them a pen, and many people innately know how to use pens and pencils. The problem with this that I have is that it's kind of hard to share this with other people. I don't mean that like, you know, sharing the space. I mean that more in the form of, you know, we've sat here for 2 hours coming up with this data model or this domain model. How can I actually give that to you? One way that you could share this with other people is like, everybody get your phone out and take a picture of it. In the case that I had with last class, what I did was I sent you a PDF copy of this diagram that I drew in class. I didn't send it to you. I put it up on the course webpage. But it's difficult to share with people in a way that makes it easy that they can make changes to it as things are going forward. Taking pictures of something with your phone is not going to be great. This can be a solved problem in a workplace where you've got literally a wall that everybody can share, and you just tape it on the wall and put markers beside it. But in our case, it's kind of hard to share this with other people with what we've got so far. This is both a good thing and a bad thing. Our diagram was pretty ad hoc. When I say ad hoc here, I mean, like, I just picked shapes. I drew a circle, and I drew lines between those things. I didn't really formally say, this is the shape that you must use to represent this idea. I picked different colors to represent things. I used like giant curly braces to say that this is what this label applies to. It was pretty ad hoc. I wasn't making formal choices about how to do this stuff. That's a really good thing because, again, there's very little barrier to entry there. If you're not thinking or worrying too much about the technical details of how something is supposed to look and just focusing on building the model itself, thinking about the problem with other people, this approach is great. But it's also not super great from the perspective of there are actually standards for stuff like this. And there are actually people who are experts in doing domain modeling. And if you just make up your own thing, they could probably figure out what you're trying to get across. But there are standardized mechanisms for us to actually describe things like a composition versus aggregation relationship. And so this is where something called UML comes in. UML is the unified modeling language. I want to pop this diagram open. This, I'm delighted to tell you this. This is a UML model diagram that describes all of the different kinds of UML model diagrams that there can be. I love that. I love that this is a recursive thing. So much of this is outside the scope of this course. The only thing that we are going to talk about in this class right now is class diagram. That's the only thing that we care about. But UML is big. It's a big thing. It's a big idea. We are focusing purely on class diagrams. UML is effectively a standardized set of shapes and notations for many different kinds of diagrams. So there's this giant UML diagram describing all the different kinds of UML diagrams, but we're just going to focus on class diagrams in this course. We really just want to have a way to draw class diagrams digitally. As I mentioned last class, what I want to do in this course is try to use two different examples from class to class to drive some of the stuff that we're talking about. Last time what we did was using music players and music management systems to describe an idea that we started to build a domain model for. And what I want to do in today's class is use Pokemon as a way to drive this forward. So effectively a game or a role-playing game. I want to make sure that we're all on the same page about what Pokemon is. And so, because I think that's important that everybody have the same kind of level of ground. If you've never played Pokemon before, I don't want that to be a disadvantage for you. I've spent, oh my gosh, an embarrassing amount of time playing Pokemon in my life. Let me tell you the story of what Pokemon is. Pokemon is a video game. It came out in the late 1990s. And the premise of the game is basically, you're a 9 to 12-year-old child. You've told your mother that you are going to leave home. You're going to leave home and you're going to go out into the world. And what you're going to do out in the world is you are going to wander around in tall grass and in caves where there are wild animals that will attack you. But you can capture and tame these wild animals. And then while you're walking around in these different areas, there are also random strangers that will approach you and challenge you to battle the tamed monsters that you have. All of this is under the guise of, I want to be the best, the very best, like no one ever was. Yes, then we hear the theme song in our heads if we've watched the TV show. Here's the idea. This is us right here. We get to wander around in this world. This person is a person that doesn't challenge us, but they stand there and we can talk to them. We wander around in tall grass, and what happens is wild animals will come out and attack us. Our trainer here, this is the name of the person. The description is that this is a trainer person. They have a collection of Pokemon. They can choose from the Pokemon. Forgive me, I was playing this with my children and they have no idea how to name anything. They just come up with random names. Also, it's a Magikarp. If you know, you know. I guess the way that we interact with this is that we can choose either to fight. Fighting is that I'm going to use a move to attack the other Pokemon. Splash, unfortunately for us, doesn't actually do anything. The best strategy that Magikarp can have is to run out of moves and then struggle, and then it can actually hurt other things. But our enemy will also be able to attack us. And the other thing that we can do in this system that we're going to be thinking about today is I can have items here. Items are things like potions. So my Pokemon have health, and I can have potions that I'm going to apply to my Pokemon to restore the health that they might have lost because something else has attacked them. If you're watching on the stream, sorry for not showing this, but here it is. This is one of the several Game Boys I brought today, but that's enough. Thank you all for putting up with me telling you about Pokemon. This is something that I personally love. This is something that I use to connect with my children. This is something that, again, I spent an embarrassing amount of time playing when I was 12 years old. That's enough about Pokemon. Here is the minimal statement that I want to use to describe Pokemon. Pokemon itself is, I believe it to be a well-known thing. It is a well-documented thing. There are lots of websites that you can go to find information about how Pokemon works, attributes, and that sort of thing. Pokemon is a big problem, and so I want to minimize what we're talking about in this class. What we're going to talk about in this class is this statement: a trainer who has Pokemon and items. Pokemon can battle each other by attacking one another, and items can be applied to Pokemon to restore health. There are many other kinds of items. There are many kinds of Pokemon. There's lots of things that we could think about with this, but I am trying to make this a minimal statement. I do not want to implement the entire game of Pokemon here. That's not the purpose of what we're doing in today's class. I want to implement just this minimal idea. I want to create a minimal UML class diagram that represents this domain model using something that is called Mermaid. Mermaid is a tool that we can use to describe UML class diagrams. There is a link to this syntax guide in today's lecture notes, so you have a link directly to this if you want. This is a comprehensive description of everything that's in UML for class diagrams. I'm going to show you what I care about in class, but there's a reference for you here if you want to have other stuff that you want to do in your class diagrams. I want to make a UML class diagram with Mermaid. I'm going to be using Visual Studio Code to do this. If you want to follow along and you don't have this extension installed, please install it now. I'm going to switch over to my VS Code, and I'm going to make a new file. I'm going to make that bigger. I'm going to make a new file, and I'm going to save this file. I'm going to save this file as a markdown file. I'm going to save it to my desktop for now, but I will share this file with you after class. I'm going to call this file readme.md. The name readme.md, I'll get to in just a second. The name readme.md is something that I'm going to prescribe, I'm going to suggest that you use this name for your file because ultimately this is going to get put into your project, not the Pokemon example, but the file that you actually create. Yeah.
Yeah, is there anything particularly special about the Mermaid's extension for VS Code? If our note-taking app already has support for Mermaid, is that fine?
Oh, yeah. If you have something that already has Mermaid support installed, then just use that. I'm just using it because I know that VS Code is a pretty common thing for people to use, and it doesn't have Mermaid support built into it. OK. So once I've got this, I'm going to make a title for my document. My document is going to be titled Franklin's Pokemon Model. And I'm going to pop open the preview to the side immediately. I want to be able to see what this is getting rendered as I'm working on this. I'm going to switch back to my slides, and I'm going to copy and paste this statement just so that we can see it all at the same time. You don't have to have this statement in yours if you don't want to, but I want to have it here just so that we can all see it together at the same time. I'm going to start drawing a diagram using Mermaid in the UML format to represent the classes that are in this model. I'm not going to ask for your feedback here. I'm just going to tell you what my model looks like in this case. To start drawing my diagram, I'm going to have to put this in a code fence. In Markdown, we have code fences by using, one way to do this is to use the backticks. The backticks are the symbol that's just above your tab key on your keyboard. And then I want this to render as a Mermaid diagram. So I'm going to change the name of this to Mermaid. If you have this Mermaid extension installed, what you're going to see immediately upon doing that is the statement of, there's nothing in here yet. I can't draw anything for you. I'm going to put some closing backticks here. I want to end where this thing is. And the very first thing I want to have in my Mermaid diagram is the word class, lowercase c, L-A-S-S, and then uppercase D diagram. Class diagram here says I want to make this into a UML class diagram, and it's describing what the kind of diagram is that I want to draw. Mermaid can draw lots of things, but we want a class diagram, so that's what we're going to use here. I'm going to put a couple of new lines in here, and I'm going to hit Tab on my keyboard. The classes that I want to put into this should be indented. I don't know if this is a specific thing with this renderer or if it is a Mermaid specific thing, but I'm just going to apply the tab here as I want to make sure this works. The way that we describe classes or things, entities in our model are going to be actually kind of similar to Java or kind of similar to JavaScript or kind of similar to Python. We have to use the word class. And then we have to give the class that we want to represent a name. So I want to represent trainers in this thing. So I'm going to say class trainer. We use curly braces. This is one way to accomplish this. This is the way I'm going to accomplish it. We use curly braces to say these are the things that are inside trainer. I don't want to have anything inside trainer yet. I just want to start with this domain model diagram. Another class that I want to have here is Pokemon. Curly brace open, and the last thing I want to have here is class item. So I've got 3 classes in my diagram right now, and then what I want to do is I want to start adding relationships between these classes. The way that I'm going to add relationships between these classes is I'm going to describe them as aggregate relationships. I'm sorry, composition. I'm going to describe these as composed relationships. So I'm going to say that the trainer is composed of a Pokemon or Pokemon instances. So the -- star says that this is going to be a composition relationship. This full diamond here says that this is a composition, and these are related to each other in composition. The other thing I want to say is that trainer is composed of items. So now I've got this relationship between my 2 classes, and the diamond here is saying that these are composition relationships. All right. While we're here, I briefly want to raise a point of clarification about the quizzes, the quiz on Friday. I am in no way asking you to memorize UML. Please do not spend time trying to memorize what the shapes are for UML. I don't want you to memorize UML. That would be not a good use of your time. There are references that you can use to see these things. That's not something that I'm interested in. Yeah.
Will we be going over what's on our quiz for the Friday?
We'll do that right now. The quiz is going to cover like the stuff that we've talked about in the today and on Monday's class. My advice to you in general would be to look at the things that I'm doing in class, the exercises that I'm asking you to do. So like what we did last class was actually beginning to draw out this domain model to represent these things, and then labeling the relationships between those two different types that we've got, or the three different types that we've got. What we're going to keep working on today is attributes and behaviors. So I expect you to start being able to do that, but again, not formally in a UML format like this. I'm not expecting you to write Mermaid code. I'm not expecting you to draw out UML diagrams. That would be painful. That would be really, really painful. I would expect you in your project to draw a UML diagram, yes, but for the quizzes, that's not important to me. Yeah, yeah.
Is there a way to write comments here?
It's a great question. The question is there a way to write comments? I'm going to go back to the Mermaid documentation here. I'm going to zoom out just a bit because I want this thing to show up on the side. On the side, there's a list of the things that are covered and comments. I realize this might be super, super small at the back, and I apologize for that. But the word comments appears here. If I click on that, the syntax for comments is %%. Those will show up just in the Mermaid source code, but they're not going to show up on the actual diagram that you're drawing. The way that you can add additional information to the class itself is to have notes attached to that if you want. So I'm going to go back up here to, I'm going to actually search for the word notes. And it shows up at the bottom. So you can have notes that show up on the diagram itself. Comments do not show up on the diagram itself. Okay, so I'm going to pop back over to my class diagram here. And now we're effectively in the same state as what we were last class. We have this model that has relationships between these two classes, and we're showing what kind of relationship is between these two classes. So I will, to the question that you've asked here, I will write here, these are composition relationships. So that we can see that they are composition relationships with the -- syntax. Okay, I'm going to switch back to my slides, but I will come back to this, this document. And like I said, I will share this with you after class. So if you are not able to get it down in class right now, I will provide you with a copy of this in some way, shape, or form. Now that we've got our domain model, we have this initial set of classes that represent, or this initial set of ideas that we're going to represent in our code and in our application eventually. We want to start thinking about adding attributes and behavior to these classes. Remember, our two goals with domain modeling are, I want to be able to communicate with peers and other people using non-technical language. But in this case, I want to have a clearer sense of what we're going to be building. We want to start working our way toward code. We do want to start working our way toward code. And the way that we're going to accomplish that is to start thinking about attributes and behaviors of classes. With attributes, what I want us to be thinking about in this class are, what are the things that we're actually going to put into a class? And what type are those things going to be in the class? So if we're thinking of Java code specifically, these are the class members that we're talking about right now. So what are the classes going to have in them? If you remember from 1020, when you were writing classes, attributes generally have types. You have to have a type that represents what this thing is. But what I want to do in this class right now is continue with non-technical language. So I don't really want us to be using the word int to describe something yet. We will eventually get to that point, but right now, in terms of non-technical language, I would prefer us to use the word number to describe something. If there's something that I must say about this number, I want to be able to use language that describes valid values for that number. So in some cases, I might want to say whole number. That eventually implies integer. It could also later imply long, but I don't want to think about these types yet. I want to think about this in terms of ways that I can communicate with somebody else working on this that doesn't have deep knowledge of the differences between int and long. They shouldn't have to care about that. I will care later. They shouldn't have to worry about it right now. So for now, what I want to use is language that describes valid values in a non-technical way. If my number should never be negative, I'm going to say positive number. If my number should always be a whole number and not have decimal points, I'm going to say whole number here. I would like to add some attributes to our domain model. And I am just going to start. I am going to do this to begin with. And I'm going to start doing this by adding attribute references to the relationships that we've got. So we specified these relationships between these classes. The implication with the relationship between these classes is that they have attributes inside of them that are the thing that we're referring to or that we're relating to here. So I'm going to go back to my diagram. And what I'm going to start to do here is I am saying that the trainer is composed of Pokemon and the trainer is composed of items. So I'm going to add a new attribute here. I'm going to say that the attribute that I've got here is a team. I'm going to say this is a private attribute. So minus means private. The other option that we have here is plus. Plus means public. This is a private thing. This is starting to be an implementation detail. I want to have it for completeness for later, but the person that we're talking to isn't thinking about this. I want you to think on this for a couple of seconds. I don't want you to dwell on it for too long. The type that we have for team is going to be some kind of a collection. I'm going to name off some types of collections that we could have. I'm going to ask you to think about it, and then I'm just going to assert what I think it should be. So the kinds of collections that I can think of are a collection. A collection is no order, it's just a group. That's all it is, it's a group. There's a set. A set implies uniqueness, so you can only have one instance of a thing in a set. You talked about sets in 1020? Yes, okay. We can have things like queues. So like they're implying the order of insertion, something that goes in first comes out first of this thing. And we can have a list. So a list implies to me that there is a sequence as opposed to just the insertion order of this. Take 3 seconds to think about this. I am going to assert that the only thing that we can say about this is that it's a collection. You might be able to say more technically yourself. If you know stuff about Pokemon, yes, there is an order to the team, but for us for now, I'm just going to say that this is a collection. Collections have types, and so I'm going to specify the type. This is that angle brackets that you would have seen in Java. What I want to say here is that this is a collection of Pokemon. Collections, we can specify using the tilde symbol. The tilde symbol is in the same place as the backtick. And so what this is saying is that a trainer has a private collection of Pokemon that are called its team. This Pokemon trainer has a collection of Pokemon that is its team. I'm also going to assert here that it's got a collection of items. So now our relationships are showing that we have this composite relationship between these types. When an instance of trainer is destroyed, any of the collection of items that are in that thing should also be destroyed with it. Any instances of item in that collection there. Likewise, any instance of Pokemon in this collection up there should be destroyed when that instance of trainer is destroyed. Yeah.
So what the items that we have for the trainer here is aggregate of item itself, right? So even if you delete the item stuff for the trainer, they will still exist items in the item table.
That's a great question. And I want to redirect your thinking to be about instances of that class as opposed to the entire class itself. A trainer is going to go to the store. Now we're talking about Pokemon. I'm sorry, everybody. We're going to go to the Pokemart and we're going to buy an instance of potion. And that is going to be added to our collection of items, but it's an instance of potion. When I destroy this trainer, when I delete it from the game, when I erase my save data and start all over again, I'm also going to erase that instance of potion. But a new trainer should be able to go to the Pokemart and buy an instance of that class. So an instance of that class may be able to exist independently outside of the tiny scope that we've defined for what this thing is right now. But for this class, for us right now, we're just going to say that it's composed of. So when we delete those references, it should also delete that instance. Okay? Okay, awesome. Okay, so we've got references to our other types here. The other thing that I'm going to add to this class set, I'm going to pop over here, is I want to add one attribute to Pokemon right now, just one. The one attribute that I want to add to Pokemon is going to be a private thing. I want it to be a positive number. And I want it to be health. Health, generally in role-playing games, never goes negative. It can become 0, but it should never go negative. So I'm giving you this information. This is a value that cannot be negative, and so I'm going to write its type right now as a positive number. I'll note that if we said int here, it doesn't say that. It says this is a whole number type, and it's within this range, but it doesn't say that it's non-negative. There are more types that we can use to describe that idea, but for now, I just want to say positive number here to indicate how much health this thing has. I'm going to pop back to my slides one last time here, and I want to start adding some attributes to trainer. Trainer here is a person. When we're thinking about these attributes, I want us to keep in mind this idea of keep it simple, and I want us to keep in mind this idea of you ain't going to need it. We're going to have to interact with this trainer type in some way, shape, or form, and so I'm going to look for some feedback from you about this. So I'll keep this up for 1 second or 2 seconds, and then I will pop over to my Mentimeter, and we can start thinking about this together. Okay, I'm going to pop over to the Mentimeter now. There's no question here, it's just a picture. That's actually about what I thought it would be. So thank you for sharing that. Let's actually go to the next question. The next question actually has a question. I want to emphasize that it's not just 2 and 3 here. It's not just 2 and 3. That is my emphasis right now. It is not just 2 and 3. A full name is something that we would probably want to give to a person, but I want to keep in mind that not everybody has the same number of names that are attached to them. And in fact, the points that I partly want to make with this is the idea that there doesn't always universally exist an idea of a first name and a last name. A first name and a last name are things that are North American or Eurocentric. These are things that we traditionally have, a first name and a last name, but that's not always going to be the case. Some people will have many, many more names than us. So what I want you to think about right now, pretty quickly here, is what kind of attributes and their types should a person have? A word that is a name, okay, yeah. Collection of the Pokemon, lots of names, clothing, okay, storage, abilities. Nickname and gender, okay. Gender, health, wins, so how many times they've won. Money, yes. So one of the key things that we get from challenging these strangers on the road is that they give us money when we eat them. I believe we also have to give them money when we lose. And then we also faint because we don't have any Pokemon left. A positive number of badges, okay, so this is something that's starting to show up in the game itself. Name and age. Losses, coins, so this is money, age, rank in the game, experience, win-loss count. Okay, awesome. These are all great. And so I'm going to pop back to my diagram, and I'm going to add a couple of these things. So my trainer here already has a collection of team and a collection of items. What I'm also going to add here, I liked the use of the word to describe. Name, this is a private thing. But I'm also going to note that it just says name. It doesn't say first name, last name, middle name. It just says name. Enter your name in this thing. And I like the idea of using the word to describe this because it's just saying type something in here. I may generalize this or more, I may specify this slightly to say text instead of name. I'm not going to say that this is words. I don't want to use the word because that implies one thing. I'm going to say text. You can type in spaces, you can type in emoji, you can type in whatever you really want. It's just some kind of text that I want to have in this thing. The other thing I'm going to say is money. I liked that idea. And so I'm going to add to this another instance of money. And I'm actually going to use the type money to represent this idea. I'm going to say that this is money, and I'm going to say that this is my balance. This is the earnings that I've gotten from this game right now. Text and money, I believe, are words that we can use to communicate with somebody that doesn't have any sense of programming, but it still gets the point across. That's what this thing is going to be. Okay, awesome. I'm going to pop back to my slides here. And now that we've got some attributes on our classes, we need to start thinking about the behaviors that we can attach to our classes. So far, when we've been coming up with these things, the classes that we've got are usually single word nouns. So a single word that describes a big idea of what we're trying to represent in this thing. Behaviors are verbs that we're going to add to our domain model. And these are also usually single words. I'm not going to say that they are universally single words, but they are usually single words to represent some action that's taking place. I would like to add some behaviors to our Pokemon domain model, and I'm going to assert these to you. I'm going to tell you what these things are. I want to add a couple of behaviors based purely on the statement that we've got here. The two verbs that I want to add are attack. I want Pokemon to be able to attack one another, and I want items to be able to be applied to a Pokemon. The decision that I want to make here is, where do these behaviors go? Which classes do they go in? And I'm going to be using technical reasons like encapsulation to justify which class gets the behavior that I'm thinking about here. Pokemon attacking each other naturally kind of fits into, there's only Pokemon involved in this thing. And so Pokemon probably have that behavior. item being applied to a Pokemon is where things kind of get a little bit uncertain. But the way that we're going to justify this with encapsulation is effectively who owns the data that's being changed by the action that we have here. So which class's property or attribute is going to be changed by the verb that we've got in this thing. I'm going to pop back to my mermaid diagram here, and I'm going to add a couple of method references to the classes that I've got right now. The way that we're going to add method references to our classes is to give them a name. I'm going to say that these are public functions. So I'm going to put a plus on them, or public methods. I'm going to say that the name of this method on Pokemon is attack. Notice that when I put that parenthesis there, it moved that method name to a different place. In UML, we have the name, we have the attributes, and then we have the methods that can be called on an instance of this thing. I'm going to say that attack belongs in Pokemon, and it takes an instance of Pokemon. I'm not going to give it a name here. I'm just saying type. This is the thing that I do eventually want to pass to this method. And I'm also going to say that this has a void return type. So I'm just putting a space after the closing parenthesis and saying there's no return type here. I believe that attack belongs here because attack is going to affect the health of a Pokemon. The Pokemon instance owns that health property. It is private to that class, and so it should be the one that makes that change. Using the same rationale, I'm going to say that the apply, and I'm going to call this apply potion. The apply potion method also belongs on Pokemon. We're talking about, I'll come to you in just a second, we're talking about a method that has two different kinds of classes that are being referred to here, Pokemon and item. But the thing that's being changed by applying this item is that the Pokemon's health is changing based on the statement that we've got here. So the method that we're writing here belongs in this class. We may need to, and we'll get to this later, we'll talk about this in a different class, but we may need to actually make changes to our item class based on what we've just described here. How much does the item change things? Yes?
You mentioned earlier that the hyphen that we used there for all the collections and pets, that represents the private.
Yes. Yep.
So when you're using a plus, do we represent this as a private function that is encapsulated in the class, or like from another class?
If we're going to specify a private method in the class, then we would put the minus sign here.
Okay,
yeah.
This could be from another class as well. The function behavior here.
I'm actually not sure I understand your question. Can I ask you to come talk to me after class? Okay, awesome. Thank you. All right. The very last thing I want to talk about today is software design principles. The ones that we're going to be talking about in this course are classified using this word solid. Solid is a set of principles that are going to be used by us to try to create code that is maintainable and reusable in different contexts. These principles that we're going to be talking about, they're more rules than the philosophies that we saw before. Again, Kiss and Yagni are a lot more like you should strive to be minimal toward the thing that you're trying to build. But there's no rule there that says you got to cut this thing off because it doesn't actually apply to the minimal thing that you're working with. These are principles, but they're not like direct directions about what you should do with your software. Solid is an acronym. I think that's the right word. The S stands for single responsibility principle. The O stands for open closed. The L stands for Liskov's substitution principle. The I is interface segregation principle. And the D is dependency inversion principle. This is a lot. Do not memorize this. Please don't memorize this list right now. That is not important to me right now. We are going to be focusing on the S of solid for this class for right now. And the idea with S is that I want to